When developers are forced to write custom authentication logic for every internal dashboard and microservice, the security posture becomes fragmented. These fragile connections often lead to inconsistent session management and eventual token leakage. Oauth2 Proxy addresses this by acting as a centralized enforcement point at the network ingress layer, intercepting traffic before it can reach your underlying services. This diagram illustrates the standalone topology. The proxy evaluates incoming requests, redirects unauthenticated users to an external identity provider, and only routes traffic to the internal server once a valid response is returned. To begin, you will need an account with an identity provider like GitHub, an open terminal, and either Docker or the compiled proxy binary. By shifting the authentication burden to the network edge, we remove the need for login code within the application, creating a centralized point of control for access. The first step is to register the proxy with your identity provider. Navigate to the developer settings and create a new OAuth application. Within those settings, you must specify an authorization callback URL. For this local test, use http://127.0.0.14180/OAuth2/callback. Your provider will then issue a client ID and a client secret. These are the specific credentials the proxy uses to communicate with the provider. Now, move to your terminal to generate the cryptographic foundation for your local session management, the cookie secret. Use this OpenSSL command to generate a 32-byte base64 encoded string. This serves as the seed for your session encryption. The proxy uses this secret to encrypt session data stored in the browser. If this string is improperly sized or missing, the proxy will fail to initialize. These three inputs, the client ID, the client secret, and the cookie secret, provide the configuration necessary to start the proxy. To see the proxy in action, we first need a target. Start a simple Python HTTP server on port 8080. Currently, if you visit localhost port 8080, the browser gains immediate access to the backend with no authentication required. We will now deploy the proxy to establish a network perimeter in front of that server. This diagram shows the --upstream flag routing the proxy to our Python server on port 8080, while --provider designates GitHub as our identity source. We then map the client ID, secret, and cookie secret into the configuration for encryption. Because we are testing over unencrypted HTTP, we must set --cookie secure to false. This prevents the browser from rejecting the session cookie, but it should only be used in local development environments. Finally, we use the --email domain flag with a wildcard to allow any authenticated user from the provider to pass through for this test. Execute the command and check the terminal logs to confirm the proxy is listening on port 4180. The target application is now isolated. The proxy stands between the public internet and the internal port, intercepting all incoming traffic. To see the handshake occur, open your browser's Network tab and navigate to the proxy on port 4180. The proxy checks for a valid session cookie. Finding none, it issues a 401 unauthorized and redirects the browser to the identity provider. Once logged in, the provider returns the browser to our callback URL, carrying a short-lived authorization code. The proxy then exchanges that code for a token, sets an encrypted cookie in your browser, and forwards the original request to the Python backend. The Network tab confirms that the unauthenticated request was stopped at the edge, never reaching the application layer until the identity was verified. You have now secured an application without modifying its source code. In a production environment, however, you must adjust this architecture for scale and security. For high-throughput environments, consider the external authorization middleware topology, where Ingress controllers like Nginx or Envoy handle the traffic and consult the proxy for identity decisions. If your identity provider returns large tokens that exceed the 4 kilobyte browser cookie limit, you will need to switch the session store to a Redis backend. To prevent header spoofing, you must also configure the --, trusted proxy IP flag. This ensures the proxy only accepts forwarding headers from your trusted load balancers. Oauth2 Proxy provides a powerful way to decouple authentication from your apps, but it requires diligent configuration and a commitment to regular patching to maintain a secure environment.